So today we will discuss about work done in an isothermal process. Work done in isothermal process. So as you know that in an isothermal process, suppose this is your system, heat exchange is allowed. That means heat can go inside and heat can come outside also from the system. So here, that means the wall is conducting wall. Such systems are called isothermal systems. So here conducting walls will be there. So in this system where the isothermal process is taking place, we can calculate the work done. If we are supplying heat, then the piston of the system, it can go up. That means the volume may increase. And in this process, by increasing the volume, in isothermal process, the temperature remain constant. T is constant. So this is the property of isothermal. Now we'll calculate the work done. Now we know that W or small work done dW is equal to P dV, pressure, and dV is the volume expanded by absorbing the heat delta Q, let's say, or Q amount of heat. Now if I want to calculate the total work done, I have to integrate P dV, and here P I can replace because P is not a constant here. P will also change. So from ideal gas equation, we know that PV is equal to, from ideal gas, we know that PV is equal to mu RT or nRT. Mu is the number of mole. Okay, it's number of mole. Now, as it is an ideal gas, temperature is constant, R is gas constant, mu is a constant, so everything is a constant. So we can write for isothermal process PV is equal to constant, K, constant. Or you can write that P is equal to constant by V. So if I replace this P value here, then I'll get K by V dV. K is a constant which I can take outside, then it will be 1 by V dV. So 1 by V dV integration is it's a non-integration, that is 1 by x dx ln x. The integration is ln x. So similarly, here the integration is ln V. Now it's a definite integral, so V volume, suppose V1 to V2. Initial volume V1, final volume becomes V2. So I can write V1 to V2. Volume varies from V1 to V2. So ln V, I'll write V1 to V2. Then you know how to calculate integration. I'll put V2 first, then V1. So I can write K ln V2 minus V1, ln V1. ln is logarithm function, log base e, that is called ln. So here you can see another property, log a minus log b is equal to log A by B. This property you know. So ln V2 minus ln V1, I can write K ln V2 by V1. So this is the what? This is the work done we found out. Now I can replace this K value. What is K? K I have replaced with your mu RT, right? Mu RT equal to K I have taken because temperature is constant in isothermal case. So if I replace it, then I'll get work done is equal to K is your mu RT ln V2 by V1. So this is the work done in case of isothermal process. And here we have taken the consideration that it's expansion. Expansion happens when work is done by the gas. Okay, in isothermal expansion, the gas absorbs it and does the work. And work is done on the gas, heat is released. So here heat absorbed and expansion happens. Heat absorbed and work done by the gas. Heat will be released work done on the gas. Work done on the gas. Okay. So this is the work done in a isothermal process. So in a next video, I'll discuss about work done in adiabatic process. Thank you.